Good morning to all of you. Topic remaining in this chapter is the reaction with pyridinium oxide. That is the oxidation of quinolines. Reaction with the oxidation of quinolines required three reagents, that is alkaline KMnO4, neutral KMnO4 and the CS3COOH as the reagents. In these reactions, the oxidation agents are used for oxidize the isoquinolines. So in first case, when the isoquinolines react with the alkaline KMnO4, then breaking of the bonds takes place at the position number 5th, and there is a formation, that is conversion of that CH into the COOH, and again the breaking at the position number 8 and conversion of the CH into COOH, means we will get the pyridine 3,4 dicarboxylic acids. Next one is the isoquinolines. That is a natural KMnO4s, neutral KMnO4 that converts the isoquinoline in the convert into the C double bond O and the 1 carbon less compounds. So we'll get the amide. Next one is the isoquinolines, that is the CS3COOH. In the isoquinolines, oxidation takes place the CS3COOH at the nitrogen atom, that the isoquinoline oxide is formed as the product. So this is all about the reactions of the isoquinolines. We know that the pyridinium oxide, quinoline and isoquinoline, these three are undergoes the same types of reactions, that is reactions chlorinations, halogenations, nitrations, amidations and reduction with the reducing agents. So all these reactions are same concept, follow the same concepts in the three compounds. Only difference is that you have to recall, you have to remind that where is this reaction is going to be takes place. Next, now we will revise all the topics what we have studied in case of the heterocyclic compounds. So in case of heterocyclic compound, we study the compounds, three structures, that is pyridinium oxides, quinoline and isoquinolines. Then we have studied the pyridinium oxide, the properties. In that, pyridinium oxide is the derivative of pyridine, in which lone pair of electron on the nitrogen is used to make a bond with the oxygens. Make the pyridinium oxide group can function as the electron acceptor as well as electron donor depending on the reagents. Next one is the pyridinium oxide is a more susceptible to electrophilic substitutions than the pyridines. Positive charge ring nitrogen act as the electron sinks to increase the nucleophilic substitutions. Both the electrophilic and the nucleophilic substitutions on the N oxides are easier than for the pyridines. As the consequences, both the electrophilic and nucleophilic substitutions occurs at the 2, 4, 6 position. Resonating structures of the pyridinium oxide is as follow. We have studied this. We have drawn these structures, so you do the practice of this. Next one is the quinolines. It is the fused heterocyclic system in which pyridine ring is the fused with the benzene ring, and it is called as 1-azonaphthalate. It is a weakly basic in nature with the pK value 4.94. This is the weak basic because in halogenation is the sp2 hybridized and it is more electron attracting. As a result, lone pair of electrons on nitrogen is more tightly held and less available for protonation. Resonating structure of quinolines are given below, and the pyridine ring is the quinolin electron deficient. Therefore, the nucleophilic attacks takes place preferably at 2-4 positions. As the pyridine ring is deactivated, the electrophilic substitution takes place preferred at 5th and 6th position, because the electrophilic attack at 5th and 8th positions, the delocalization of charges without the descriptions of the pyridine ring aromatic natures, while they are at 6th and 8th positions, it will cause descriptions that resonance in the compounds. So we draw the resonating structures of the electrophilic attack at position number 5. Here we are given the numbers 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. The structure 1st, 2nd and 6th, 7th are the more stable. Structure 3rd, 4th, 5th are the least stable, and electrophilic attack at the position 8 is also given here. Structure 1st, 2nd, 6th, 7th are more stable, and the structure 3rd, 4th, 5th are the least stable structures. Electrophilic attack at the 6th and 7th position give only top stable intermediate carbocation resonating structures. These are the resonating structures. Again, we draw the electrophilic attack at position number 8. Next is the electrophilic substitution at the position number 5th and 8th give the delocalization without disturbing the pyridine ring aromatic natures, while that at the 6th and 7th position it will cause the disruptions of the ring and the aromaticity get disturbed. This is explanatory comparison relative substitutions of the intermediate carbocations formed by the electrophilic attacks at different positions. Next one is the preparation of pyridine peroxides. Here using the different method that the pyridine can be easily oxidized by alkaline hydroperoxides or per acid and obtain the pyridine peroxide. The reactions and structure is also given here. Next one is the preparation of keonolins. The quinolin preparations is a 3-step process. In the first step, glycerol is dehydrated by using the concentrated H2SO4 to give the acrolein. The next one is the acrolein is reacts with the aniline by the Michael addition reactions, give the 3-N-phenyl amino acrolines plus anilines gives the 3-N-phenyl amino propanol as the product. Step 3rd, acid catalyzed cyclizations of the reactants of the earlier process and give the dihydroquinolin as the products. In step 4th, nitrogen used to dehydrogenation of the hydrogen of the quinolins. Next we will get the final products. This is all about the 4th step. Next one is the preparation of isoquanolines. In that we are using the condensations of the benzaldehyde with the nitromethanes in presence of the base to give the products. That products react with the lithium aluminum hydride, that is reducing it, and give the beta phenyl ethyl amines, which is on acetylizations, that is acetizations of the beta phenyl ethylamines, followed by the heating of the PCl5 undergoes the cyclodehydration to give the 3,4-dihydroquinolines. So this is all about the next product form, that is 3,4-dihydroquinolin as the product. Next one is the step 5, dehydrogenation of the 3,4-dihydroquinolines by palladium carbons to give the isoquinolin as the product of these reactions. Next one is the reactions of the pyridine oxides. Here is the first is the halogenation reactions. For the halogenation reaction, the reagent used is the SOCl2 plus POCl3. Halogenation takes place at 2 and 4 positions. Next one is the bromination of the pyridine oxides. Reagent used is the Br2 plus 72 degrees centigrade. Product formed at the 3 and 3 position, 3 bromopyridine and 3 bromopyridine is the product. Next one is nitration reactions. Nitration reaction reagent used as the concentrated H2SO4 plus phosphorating HNO3. Product formed at the 4th position, that is the 4-nitropyridine oxides. Next one is the amylations. The amylating agent is liquid NH3 plus NaNH2. Product formed at the 2 position, that is 2-aminopyridine N oxide and 3-aminopyridine N oxides. Next one is the reactor with the N-butyl lithium gives the butyl lithium at the position number 4. Reaction of Keonolins. One is the halogenations. In that there are 2 consecutive H2SO4 react and product form at the 5th and 8th positions. Next in nitration reactions, nitration takes place at the position number 5th and the position number 8. We will get the 5-nitro-quinolin and the 5-nitro-8-nitro-quinolin. Next is the amylations. In that the reagent is the NaNH2, sodium nitrite, liquid NH3, KMnO4 at -66 degrees centigrade, and another reaction is that -40 degrees centigrade, 60 degrees centigrade, 66 degrees centigrade product form at the 2 positions, -40 degrees centigrade product form at the 4 positions. Next is the reaction with the N-butyl lithium. In the reactions in N-butyl lithium, the N-butyl lithium benzene reactions temperatures and the product forms is the H2O. Next one, reaction with the reducing agents in quinolin. Either the pyridine or the benzene ring can be selectively reduced, that is give the quinolin as the product. And H2PT CS3OH1234 tetrahydroquinolin as the intermediate product. So this is all about the reactions. Next one is the reactions with the quinolin, that H2PT and HCl react with the quinolins and reduces the 5,6,7,8 tetrahydroquinolin as the products. Next one is the quinolin react with lithium and NH3 gives the 1,4-dihydroquinolins. Next, quinolin react with the lithium aluminum hydride CS3CH2 diethyl oxygen 1,2-dihydroquinolin as the product. Reaction with the oxidizing agents alkaline KMnO4 reduces at the position number 5 pyridine to 3-dicarboxylic acid. Next, quinolin as the glycine and pyridine to 3-diethyl is the product. Next reagent is the CS3COOH, that is peracid. React with the quinolins, give the quinolin N oxide as the product. Reaction of the isoquanolines. First is the halogenation reactions. Halogenation reactions of the isoquanolines by using Br2AlCl3 75 degrees centigrade pressure with the 5-bromoquinolin and 8-bromocurin. Next is the nitrations. Isoquanolines react with the 5th position, that is 90% 5-nitro-isoquanolins. Amylations takes place at the 1 position, that is 1-amines in NH2NH3 reaction with the N-lithium butyl lithium's room temperature gives the first, that is butyl group, which is on final gives the N-butyl isoquinolin as the products. The reaction with the reducing agents, that is the quinolins, react with the 2 reagents H2PT and H2PT to normal HCl. First H2PT CS3OH reduces the rings containing nitrogen atoms, and second one is the H2PT to normal HCl reduces the benzene rings. Next lithium in the NH3 liquid NH3, the quinolin converted into the 3,4-dihydroisoquinolin, and the reactions takes place the 1,2-dihydroisoquinolin. So this is all about the reactions which we are on the last step, that is the reaction with the oxidizing agents. Isoquinolin react with the alkaline KMnO4 gives the pyridine 3,4-dicarboxylic acid. Isoquinolins react with the neutral KMnO4 gives the oxidations at the position number with less 1 carbon atoms. And isoquinolin react with CH3COH gives the isoquinolin and oxide. This is all about the heterocyclic compounds. Please study these topics in the next topics in the next lecture. Thank you very much.